Similar polygons, day one. All right, we've talked about congruent polygons in the past. So remember, congruent polygons had three things that they had in common. Does anybody remember? They had the same, what is it? Say shape? No. Yeah, all the sides are the same length. What else? Anybody remember? Sides are the same length, the angles were the same, and the same number of sides. Okay? So those are the three things. Number of sides, angles, and sides were all the same. Okay? They were completely the same. They were congruent. Today we're discussing similar polygons. They have 2 out of the 3. Okay? So they have the same angles and the same shape or same number of sides, but they're different sizes. Okay? So like they might both be triangles and they might both have the same angle sizes, but one's gonna be bigger than the other. Okay? So the best way I can help you like to think about it in a real world situation is, has anybody ever seen like a model car or a model truck or little model airplanes or something like that? Y'all ever played with those or built to them or anything like that? Okay. So when you do that, when you a lot of times if you look on the box, they'll say like a 1/32 scale or something like that, right? Okay. And what that means is say it's a model plane, and say the real plane's wing was 10 feet. When they made the little model, the little toy, they took that 10 feet and they took and multiplied it times 1/32. And what they did is they got like a percentage, a scale factor, and they scaled it down. Okay? So if you were to measure the angles and everything on a real model versus the real plane, all the angles and all that stuff would be the same. They just sized it down so that everything's in the same spot. It like measures the same angle wise. It's just they're different sizes. Okay? Does that make sense? And so they use what we call a scale factor to size it down. And so they measure the wing, okay, 10 foot times 1/32, they give me the size of the model. Measure the tire size, okay, measure that times 1/32. Now I can see what the little model's tire is going to be. And they do that for every single part. And that gives me the scaled down version of it. All right. So that's basically what we're doing today with polygons. So let's look at this example. Example 1. It says list all the congruent angles and write the statement of proportionality. Okay. Before we even get started, I want to take note of what this is right here. So this is called a similarity statement. Make sure you write that down. Similarity statement. All right, we've dealt with these like before. They're really close, but we call them congruent statements. The only thing different is if you look at the symbol in the middle, this is a similar symbol. Okay, and I gave y'all a chart here. So similar, it's just a little tilde. Equal to, we know what that is, and then of course the congruent with the tilde on top. All right, so we're dealing with similarities today. So same thing, just different symbol in the middle. All right, so when it tells me to list out the congruent angles, it's going to be just like we've done before. I'm going to pick like angle A. I'm going to look at A, and it's in the first part. Which one's in the first part on this side, on this triangle? D. So it's going to be angle A is congruent to angle D. So for our first one here, angle A is congruent to angle D. Okay. And then we just finish it all out. So do it for every single angle. And how many angles does a triangle have? 3. Okay. However many sides they have is how many angles they'll have. So if we'll have 3 pairs. If you had a 5-sided polygon, you would have 5 pairs of angles. So the next one's going to be angle B. Which one goes with angle B, class? E. And then the last one is angle C. And which one goes with it? Angle F. Okay? So there's my congruent angles. And I forgot to say it, but this example is like how you do number 1 through 4 on your worksheet. All right? All right, so that's nothing new. That's our congruent angles. But now what we're going to do is write a statement of proportionality. And so this is completely new. You haven't done this one yet. And what we do with this, and I highly recommend if you use different colors, this is a good time to do so. But we're going to match up. And we talked about this yesterday, but we're going to, a proportion. Because a proportion, remember, is a ratio, which is basically a fraction, and it's set equal to another one. That's the same thing, right? So we're going to make a big proportion with all of the sides. So for example, I'm going to start with side AB. And I'm going to take one color, and I'm just going to draw a little line on AB. Even if you don't use colors, I highly recommend you at least like scratch it out or something so you don't use the same sign twice. Okay? So, and then I'm going to write down here AB. And I'm going to make a ratio. So I'm going to put it as a fraction. And now what I need to do is see which side on the bigger triangle matches up with AB, or is corresponding. It's in the same position. And remember, I look up here at my statement. AB is the first and second one. So DE is the first and second. So DE goes with it. So I'm going to put DE at the bottom. So I always recommend you use that statement there. Because if you just look at it, this one's nice because they're in the same direction. But sometimes they take the second one and they spin it. They rotate it to where it looks different. So it's not as easy to see. Or if you have a polygon that's got like 6 sides or something like that, it's really hard to tell which ones go together. So use your similarity statement. All right, so I'm going to get a different color. And I'm just going to pick another one from this triangle. So I'll pick BC. Which one goes with BC, class? EF. So I'm going to put BC over EF. Now take note, if you started out with the small one on top, keep the small one sides on the top all the way across, okay? Don't switch it up and put the big one on the top or something like that. So then I got to mark it. So those blue ones go together. And lastly, we got AC. And what goes with that one? DF. Okay. Now, we got all 3 sides. We got the statement of proportionality. So we're done. Okay. Once again, if it had 5 sides, you'd have 5 little ratios. 6, you'd have 6, and so on. Example 2. Are they similar? If yes, write a similarity statement and find the scale factor. So, if it's no, do we write a similarity statement and do a scale factor? If we get no? No. Okay. So if you get no, you find out it's not even similar, you're done. You just put no and move on with your life. So, but first thing we want to do to find out if they're similar is we're going to use that statement of proportionality. Okay? It didn't ask me to write one like the last one did, but what you need to do is for all of these, it's good to write one, and then it can help you solve for it as well. So let's do a statement of proportionality. So Angel, pick one side. I don't care what side, but one side from that left triangle. BA. Okay, so I'm going to do that in red. BA. Lucas, which one matches up with BA? DF. Now, class, this one didn't have a similarity statement, but how did I know that DF and BA go together?
Because the right angle.
Good.
And the thing at the top.
Perfect. Okay. Because when I looked at BA, it had a right angle, and it had the little angle there that just had the one little curve. So I knew my side was attached to that. So I got to go to the other triangle and look for the right angle and the single curve, and I know that side's going to match up. All right, good job, guys. All right, next. Jules, pick another one from the left triangle. BC. Okay. And Luis, which one matches up with BC? DE. All right. Last one. Hernan, what's the one on the small one? And which one is a matchup on the big one? AC and FE. Okay. All right, so I got my statement of proportionality. Now what I'm going to do is I'm going to plug in all the numbers for this one. Okay, so this one we got to actually plug in numbers. So you just simply go through. You look at BA. BA was 3. So I'm going to put in 3 for it. DF was 6, so I'm going to put in 6. All right, y'all fill me in. What is the rest of them? What's the next one? What over what? 5 over 10, and then 4 over 8. All right. So yesterday we had something similar to this. We had a proportion, and I said we got to do something to each of these in order to be able to tell if they were similar. Do y'all remember? Yeah, that's how you do it. What is that called, though, when we do that? Reducing. Yeah, so make note. We want to reduce these. Okay? Make sure you write reduce, because that way you don't look at your notes later and ask yourself, what in the world did we do there? Okay? All right, so reduce each of those. 3 over 6, math enter. 5 divided by 10, math enter with your calculator. Mandy, what'd you get when you reduce 1 over 3 over 6? Perfect, so 1 over 2. Shelby, 5 over 10? Okay, good. And Mateo, 4 over 8. 1 over 2. All right, so we got 1/2 for each of these. If they are all the same, they're similar. So are these all the same? Yeah. So our answer is yes. They are similar because they equal. All right. And we can just circle it here as well. Okay, on your worksheet, like I said, I don't think it tells you to say the Y, but just make sure you write it down here so that you know. Next, I need to write a similarity statement. So remember I showed you what the similarity statement looked like before? It was like triangle, is similar to the other triangle. So this triangle, Roman, name that little triangle for me. I don't care what you name it. Just tell me a name for it.
BCA.
Yeah, that works. So triangle BCA. And then it's similar to triangle. Noah, which one matches up with B?
D.
D? How'd you know that?
Because it's in the same place. It's the same.
Okay, the same angles, right? They're the same angles. Okay. Angie, which one matches with C? Which one? E? And then Chris, which one matches up with A? F. There's my similarity statement. Okay? You just name the first one and then find which letters match up with it on that one. Okay. Last part is the scale factor. So like I told y'all earlier with like a model airplane or whatever, the scale factor is what number we can use to figure out like the size differences. So the good thing is we've already found the scale factor. It's just simply the numbers that you reduced that all equaled each other. Okay? So our scale factor is just 1 over 2. And what that says is because we had the small triangle on top and the big triangle's numbers on bottom. And when I reduced it, it says that my small triangle is 1, my big triangle is 2. So to get from 1 to 2, I double it, right? So when I look at my little triangle, side BA is 3, side DF is 6. So I had to double that to get there, right? Okay? Or if I go backwards, I cut it in half to get there. So literally a small triangle, the sides are half the size of the big one. All right? And that's what the scale factor tells us, is how to find like the size difference.